Okay, so we are going to go over 4.7, a couple more of these like sine, cosine, and tangent problems, but asked in a different way. So we'll just pick a couple of these and see how we do. Okay, so number one says the side lengths of right triangle ABC are 13, 5, and 12. If 5 is the numerator of cosine of A in the triangle, what is the trig ratio for the sine of A? And you're like, what? And you're like, why, Miss Johnson? Okay, so first of all, the biggest thing that they're missing here is a picture. And so I'm going to quote my favorite math teacher from high school. He used to say, draw a picture. So sometimes he would like put like funny words in there, like draw a freaking picture. And he was from Boston. So it would always sound funnier to me because I don't know, people with accents just automatically sound more serious. So the first thing I'm going to do is I'm going to draw this triangle ABC. Now, if I draw it wrong and I label it wrong because of the clues that they've given me, I reserve the right to completely erase and fix it. Okay. So I'm just going to draw any old right triangle. So I'll draw this like this. I'll label this my right angle. And it says side lengths of right triangle ABC are 13, 5, and 12. If 5 is the numerator of cosine of A in the triangle, what is the trig ratio for sine of A? So there's actually several ways for you to do this. Once you really understand this, you don't actually need a picture, but I'm going to draw a picture because I need a picture. I'm going to draw a picture because you may not understand how to do this, and it's just easier to follow. So the first thing I'm going to do is I'm going to label my triangle sides with 13, 5, and 12. Now, because you know a little bit about right triangles, you should know which there's one side that has to go on one of the sides. Has to. Like you have to put this number there. The other two numbers, they can flip flop. It doesn't really matter. And I generically kind of drew these. Well, this one looks way shorter than that one, but usually I'll draw it generic so that it would fit either way. Okay. So because of that, I'm going to put this as 13. 13 has to go here. Has to. Why does 13 have to go here? Yeah. Number one, he's the biggest number. So therefore, he gets the largest side, who was always going to be opposite the largest angle, which is, in fact, the 90 degrees. So if you put 13 anywhere else, you're wrong. Now, for these two here, you can flip flop it. Doesn't matter. But just for like, kind of like naming sake, because this looks shorter, I'm going to make this 5, even though it should have been way shorter, right? But this is again not drawn to scale. Okay. So I did this sentence. There's nothing else. I squeezed every bit of information that I could out of here. So then I moved to my second sentence. Second sentence says, if 5 is the numerator of cosine A. Wait a second. I remember this. Miss Johnson, you taught us about cosine A in that last video. You said cosine of an angle is equal to adjacent over hypotenuse. Here, my hypotenuse has to be 13 because that's what the hypotenuse is. But here they're telling me that 5 is the numerator. So you want me to put a 5 up here, Miss Johnson? Well, no, I don't want you. They said to. If 5 is the numerator of cosine of A. Oh, okay. In the triangle. Okay, so cosine is adjacent. Who's this guy adjacent to? Now, some of you want to put A here. Now, no, because if you're saying cosine of A is adjacent over hypotenuse, and it's giving you a value like this, 5 over 13, that means A is either here or here, not here. A cannot be here. A cannot be here. A cannot be here because that's the 90-degree angle. And then if you look, both of these are adjacent, right? And that doesn't make sense. Hey, Ms. Johnson, isn't hypotenuse adjacent to this guy too? And the answer is yes, except for he has a name. He's the hypotenuse all the time. If you're saying that this is the opposite, he's the opposite of an angle. Remember we wrote that the last time? So I need to know which angle is adjacent to 5. So who's adjacent to 5? And you're like, this one, Miss Johnson. Okay, then he deserves to be named A. Why is he A, Miss Johnson? Because according to what you just wrote here, cosine of A is equal to adjacent over hypotenuse. And then according to that, the adjacent is 5 and the hypotenuse is 13. So this matches. Okay. So then they actually want to know what's the sine of A. What the sine of A is. And you like in reality, after reading this first sentence and then reading what they want you to find, you should have already known that the denominator was going to have to be 13 because that's what sine is. Sine is opposite over hypotenuse. Sorry, I should have written that down. Oops. Let me write that down. So this is opposite over hypotenuse. So we already knew that was 13. Now I just need to know who's opposite. So if like reading this clue, right? We got this, and now we know that the opposite is this side across from angle A, this guy, right? So that means I have to put a 12 on the top. Now, some of you are thinking, Ms. Johnson, you didn't need to draw this picture. I know, right? But the picture verifies and validates all of your thinking right here. Now, some of you read this and were like, oh, if 5 is the cosine, that means 12 is the sine and 13 is your hypotenuse. So it's 12 over 13. Done, Miss Johnson. Yes, absolutely. When you've worked with sine, cosine, and tangent enough, you would be able to see all of those pieces together. For those of you who are like, what did you just say? Just practice. I promise. The more you practice with this, the more it makes sense. The more it makes sense, the more fluid you can go in between different things. Okay. So that's that one. So I'm going to have you guys try this one. It says the side lengths of right triangles EFG are 20, 29, and 21. If 20 is the numerator for cosine of E, what's the tangent? So if you're going to draw the picture, I would draw the picture. I would lay out what they gave you cosine of E. And then I would lay out what tangent of E is and then start labeling as much as I can. So I'm going to pause really quick just so that you can practice, because practicing is huge. This is one of those things, right? Don't think, oh, I could just guess and I could just do all that. Don't. Like really practice. Okay. I wouldn't necessarily use the shortcut without using the drawing in this case. If you're uncomfortable, I would go for the drawing. Okay, so I'm going to pause it really quick so you guys can practice. Okay, for this one, it says this side, again, all of these are going to be the exact same kind of process, except they're alternating, right? They use cosine and sine, cosine and tangent. Let's see, they give you sine and cosine, cosine, sine, sine, cosine, right? Here, they're actually using the same letter, same angle. And then here, they've switched it. Let's see, this one. Yeah, these two, they switched. So I'm going to skip number 2 for now and then jump to number 5 just to make sure that you got this. Actually, I'll show you the answers for this just so that you have it and you've checked it. So again, I'm going to draw that right triangle. I like to draw my right triangles different every single time because someone said one time, oh, that triangle is upside down. And I was like, triangles can't be upside down because triangles, there's no right side up for them. Right? So I make this right triangle like this. Let's see, 29, it has to be my hypotenuse. And then 21 and 20. And then it says 20 is the numerator for cosine of E. So if this is the numerator for cosine of E, that tells me this is E, right? This is E. Find the tangent for E. So tangent of E is 21 over 20. Okay. I'm going to do this one, number 5, with you before we stop this video because this one's a little different because we switched angles and I want to make sure that you guys are comfortable with that. So the very first thing I'm going to do is label. So I'm going to give you a couple seconds to go ahead and label your triangle while I draw my triangle as well. And again, I like drawing them in like different orientations so that you guys are comfortable seeing triangles in different ways. And it's okay if you're like, Miss Johnson, my triangles don't look like right triangles. That's okay. That's why I keep drawing this little right angle symbol in here so that you see it. Okay. Okay, sorry. And this is this one. Okay. So then it says that 33, 56, and 65 are the side lengths. So clearly my hypotenuse is 65. Let me try syncing this. It's not syncing. All right, let me try one more thing. Right, there it goes. Okay, so then I'm just going to label the other two sides 33 and 56. Okay. It is going to catch up, I promise. It's just a little slow. Okay. Oh, there it goes. Okay. And then it says, if 56 is the numerator for sine of y, if 56 is the numerator, so I'm going to write 56 is the numerator. And obviously that would mean 65 is the denominator, right? If this is the numerator, and you know that sine is opposite over hypotenuse, that means 56 is the opposite of y. 56 is the opposite of y. So this side here is the opposite side to which angle? This angle or this angle? And you're like, why not this angle? Never the 90-degree angle, right? Because opposite to the 90-degree angle is going to be your hypotenuse all the time. So opposite of this would be this angle here. So I'm going to label that guy y. Okay, that's my y. And then now they want to know what's the trig ratio for cosine of x. So because they're actually asking you for the trig ratio of cosine x given this triangle, so you could assume that this angle here is going to be x. Okay. This angle here is going to be x. So then the cosine of this is going to be 56 over 65, which that's like what you guys realized earlier, which was, Miss Johnson, that guy's sine is that guy's cosine. Okay, that guy's sine is that guy's cosine. This guy's sine is this guy's cosine, right? So that is a relationship. So now you should be able to do these. Again, these are going to be reviewed because we will be using this in a little bit. You should feel a little bit more comfortable. It's okay if you're not completely comfortable with knowing how to do every single one of these problems. Your idea is now you understand it a little bit more than when we first started recording this, right? All right. Thanks for listening.